This week on Outdoor Oklahoma, the northern bobwhite quail might be the king of upland bird hunting, yet their numbers today are nothing like they once were. Find out how satellites in space are helping biologists work toward long-term solutions for the northern bobwhite quail, right now on Outdoor Oklahoma.
Whoop, whoop, there we go. Shoot, good shot, way to go. Now you're kind of getting to see the hang of it. Guarantee you they've been here. Be careful shooting over the hill that the dog doesn't jump up. Okay, whoa! Good shot.
Did you get one?
Yeah. Nice work on the dog. Whoa. 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 Go ahead, Wes. Whoa. 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 Good shot. Two coveys. Get your bird?
Yep, two coveys, two birds.
Well, hello and welcome to Outdoor Oklahoma. I'm Todd Craighead. Oklahoma's rich quail hunting heritage is as old as our state, and our reputation for great quail hunting opportunities, especially on public lands, is known nationwide. And as the northern bobwhite quail numbers have decreased over much of the country over the years, the wildlife scientific community at large has been looking to us to help understand why. We've led the way with research more than once over the decades. First with a long-term quail mortality study, and then more recently another study that focused on diseases in northern bobwhite quail. And today, the Wildlife Department has partnered with researchers at Oklahoma State University for a groundbreaking new research project that is giving us insight about quail behavior that has never even been possible to know before.
Well, quail are definitely part of Oklahoma's history. Quail hunting has been a long-standing tradition here in the state with bird dogs, and all the way back to statehood and before, quail thrived here in Oklahoma. And not too long ago, back in 40, 50 years ago, there were over 3 million quail being harvested in the state. So in 1990, our research consisted of trying to find out as much as we could as quick as possible. So we were using VHF transmitters, which you use an old antenna like you would use to pick up 4, 5, and 9 when you were a kid. And they've got the quail wear a little necklace that transmits a certain signal. From there to today, we've actually started using solar-powered GPS backpacks. Under the old VHF technology, we could maybe get 2 or 3 points per quail per day on one WMA. By using these satellite transmitters, we've been able to broaden our horizons to doing research on 4 different wildlife management areas that instead of getting 2 points per bird, we're getting up to 18 points per bird. So the amount of data that we're getting alone is a game changer. But when we look at how that quail is moving throughout a day, since we're getting 18 points throughout the day, we know, oh, it hit under this bush at 2 o'clock in the afternoon. That then allows research to go in ground truth, to really be able to say why was this quail here at this part of the day? Are other quail in the area in the same type of habitat? It gives us a lot better of an idea of how the quail is using that habitat, how it's interacting with management strategies and techniques that we're applying to the landscape as land managers. And ultimately, it gives us the best information to be able to share with public landowners or private landowners to be able to make the best impact on their properties as well, so that at the end of the day, our quail population will bounce back up a little bit.
We have 12 bait sites with an average of about 6 traps per site. Yeah, the ultimate goal is to get a wide range of spacing in the WMA. So we'll catch like maybe input radio transmitters on maybe about 5 to 7. And like the northeast, they'll move to the southwest and catch another 5 to 7. And so on and so forth throughout the rest of the property. Well, first, what I'm primarily going to look at is the sex of the quail. This one's a female, has buffy bands around the eye, as also around the chin. And all quail are magnificently camouflaged from above to be hidden from predators. This one, next after that, I'm going to look at the age of the bird. If you notice the buffy tips on the primary culverts, you'll see that there's looks like a triangle of gray or buffiness. That indicates that they are a juvenile. After their first year, they're going to molt those primary culverts. Now that we have determined their age and sex, we're now going to put them in this bag to weigh them. As gently as you can. Fold the entire bag a few times so that there's no chance for them to escape. Weigh it, shake the scale, because a lot of times this particular model will stick. 160, 170, 180, and she weighs 185. We're now about to band their right leg. Band will give us the top number, gives us a good ID. This girl is 5566. There is also a phone number on her, so if you do happen to find the band either through hunting or through another means, you can call the number and just to kind of give a report that they found this band, the quail's dead. And the band you can actually keep. However, if there's a radio or a satellite transmitter on, we do ask that you give them back to us. Right. Alright, we're going to put the satellite on as tightly as possible. We do want there to be some wiggle room so it's not like cutting off circulation or preventing flight. We've tried to get every single flight feather within the band and not trapped outside of the band. to allow for an ease of movement. We are now clamping them. If you don't clamp them, they'll easily just fall off. We had an instance where we forgot to clamp them, and when we went to go track them, we found a radio. We thought the quail was dead. However, he had just slipped off the radio. We don't want the Teflon ribbon to get tangled with anything, so we just go ahead and cut them. To prevent unraveling, we will burn the edges. I'm covering the quail's head primarily just to stop them from getting nervous around the fire. Alright, you've been a good quail.
Solar-powered transmitters. They actually have probably a life of up to a year or even longer. The transmitter will send a signal to the satellite and of the location, and we're able to download this data periodically from the satellite, and so we're basically getting instantaneous locations from these birds throughout the year. And so it's providing us data that we have never previously been able to collect on quail.
And also how they change throughout the day. So it's really good at giving us sort of a clip of what it's like to be a quail and how to deal with looking for food or dealing with temperature stress, as well as ultimately another thing that we can get from these is how do they move far. So when they make these big movements across the landscapes where they may move off of one person's property onto another one, we can get a good measure of why and how they move. And
ultimately just really trying to see how quail operate on a daily basis.
So here we have an animation of all the locations gathered during 5 months from the single female bobwhite. It starts up down here where we trapped it. Each dot represents a GPS fix, and then it just draws a line between adjacent fixes so you see in what direction it moves. And shortly after we tagged it, as you saw, I'm going to pause it here, it made a displacement movement. 3 days after we caught it, it moved about 1.5 miles to the northeast. And then it pretty much stayed there for the rest of the time we had a tag on it. And whenever you see the little green arrow sit still for a while, that's the nighttime roost. This kind of detailed location data has never really been collected, at least not on this scale. I mean, it's quite fascinating to see how they move around, how they utilize the landscape. This is new to science, really. I mean, as a scientist, whenever you get your hands on something that hasn't been seen before, that's awesome. I mean, this level of detail is fantastic. This really enables us to better understand how quail utilize the landscape, what kind of landscape features, shrubs, etc. that they utilize, when they utilize them, how they might be important, and then by extension we get an idea on how we are supposed to manage the landscape to make it suitable for quail. And so, yeah, in Oklahoma for sure, this is a unique study, and even I would say in terms of throughout the U.S. that this is a study that we haven't really seen on quail for sure.
Well, one really interesting aspect of it that I think is unique is that we have, first of all, we have these GPS devices, but we also have 4 very different WMAs. So usually these studies, first of all, most studies don't use these devices, but then in addition, they're usually on one site.
The amount of data we're able to collect from these birds It is astronomical when you start thinking about the number of locations we can get from an individual bird over a season. And so that data gives us opportunity to really look more at what is driving movements of these birds, how they're responding to habitat. And so we're getting on a daily basis, getting on average 13 locations on each individual bird, which we never had the ability to do before when we were doing traditional radio telemetry. And so to me, that is a pretty cool aspect of this project.
The researchers at Oklahoma State University are analyzing all of the data that's coming in off of these satellite transmitters. Hand in hand, they're also looking at plant life communities around these WMAs, insect life communities around these WMAs, and being able to paint a really broad picture as to every square inch of what's going on this wildlife management area. Why is a quail there? What's so special about that particular spot? And there's a team of probably 7 or 8 different individuals that are working every day to try to analyze this data and get it turned around into a usable product that we can in turn get back out to the people of Oklahoma.
So my role is to look at quail interactions with their landscape. Specifically, I want to know how they interact with woody cover, because we know that quail need woody cover, but we also know that a certain amount of woody cover starts to sort of push them out. So what I'm doing here is taking these GPS locations, and each of these little green dots represents where a quail was, and then using that over multiple birds over multiple years and trying to figure out where birds consistently are and where they consistently aren't. And then lining that up with certain environmental variables, such as different types of woody cover, to sort of start to begin to see a clearer picture of what levels of woody cover are most helpful for quail. Each of those little green dots represents where a quail was, and those dots are on one particular female quail, so one hen, over the course of, I think that's winter time data there. So that's how she's spending her winter. So presumably she's in a covey at this point, and each of those fixes, each of those dots, is where she is each hour. And on the left screen here is a heat map over a lot of tagged birds in 1 year, and so that is where areas where birds are consistently using are in red, and the blue areas are where they are typically not found. Now that we have these heat maps, and now that we kind of know where quail tend to be, we can now line that up with environmental data. So for example, John McQuaig is working on some woody cover data, and we can find out what about that certain types of woody cover can best facilitate high quail populations.
I'm looking primarily at habitat data. I'm quantifying vegetation, so plant communities, and then also different ground covers, so litter, bare ground, different plant types. And basically what that's doing is mapping out a base map for the telemetry work, seeing where these quail are moving, what type of plant communities they're utilizing, and getting information with that on how to better manage plant communities for quail.
I'm working on looking at the whole bird community. So we did point counts this summer and collected data on what bird species existed on all 4 of the WMAs. And I'm going to look at the vegetation data that John collected and then compare the two, see if there's any correlation. This is a map of Beaver River WMA, and each one of these points is a randomized location where we would do a point count. And then on the left screen, this is the data that came out of each point count. So it has the start time, end time, and then each bird that we saw or heard at the location. Worked from sunrise to 4 hours after each day of the summer. So we collected just as many points as we could get done in that time period. This summer we actually got about 700 points done. So 700 point counts done throughout the summer.
I'm looking at bobwhite movement, but more than just movement, looking at basically you have a bird on the landscape. Why does it do what it does? So we're looking at landscape change, things like differences in shrubs to roads. So when you take GPS coordinates on these tags, you get lat and long. And basically then what we can do is we can take this data and then plot it onto the landscape, and which creates lines. So here's a line. This is the point from here to here, and that line is roughly 221 meters. So then we can take this distance data, we can do all sorts of other things. We can do turning angle, which is basically like which degree does the bird go in like a 360 degrees. And that starts to answer like these landscape questions about why the bird's moving the way it is. And here's one bird, for example, this bird is its whole life, or not life, but it's whole 6 months we had the tag life. So I've broken it down based on month, so you can take like, so here's June. So June, it covered this range, and then into August, it was further down here, and you can see this really tight line pattern. It's basically, that means there's probably a nest in here somewhere. And then in October, it starts to move a little more, and by November, it's bolted across the road, and then it winters on this patch over here. So basically, you can like take this data and this kind of stuff, and you can start asking why is it moving the way it is, and you can look at landscape features. Like there's a highway right here, and you can see the bird is like hesitant to move across the highway that comes across.
One of the things that I think is exciting 5 or 10 years down the road, if we collect a lot of this information that is missing from the quail research, is the understanding of what connects different populations of quail, so across a landscape. So if you think of western Oklahoma, we have cropland, we have woodlands, we have grasslands, we have shrublands, have some places suitable for quail, some places not. What happens to these populations is that sometimes these local areas will blink out, and in order for that location to have quail have to move into that. And we really, based on the old technology, are unable to answer those questions.
We hope that this research will provide us some guidance in terms of how quail respond to some of these management practices, and what amount of shrubby habitat on the landscape is going to be good for quail. We can hopefully be able to our ODWC and private landowners can apply that to future management prescriptions, and ultimately we can see that as being a benefit for quail.
So we want to make sure as an agency that's managing our wildlife resources that if people want to be able to pursue them, then we're doing our best to be able to make sure that that animal is there to pursue. Plus, it's our job as an agency managing the wildlife to make sure that it's being managed efficiently and effectively and in a way that doesn't negatively impact that species. And so by doing the research, we then have the data to come to a landowner or a sportsman's club or anything like that to say, this is what we need to do to ensure that we have quail tomorrow and 5 years from now and 10 years from now. So we need to start working today.
I'm a faculty member in natural resource ecology and management, but a large portion of the responsibilities that I have are for doing extension. And extension is just taking the science that we're finding here at the research and taking that to the public and telling them what we're finding. And so I work for the Oklahoma Cooperative Extension Service, and so we have specialists, which are folks that are faculty on campus here that help our county educators in providing field days and those kinds of things. So we have some demonstration plots at each of the WMAs, and what we're doing with those is we're burning in different seasons. And so we have dormant season burns and growing season burns, and we're collecting information about what the vegetation does in response to those burns. And so we'll be using those for the field days to show people how the plants respond to these different burn treatments, so they can implement those on their own ranches depending on what their management objectives are.
Well, I hope it makes you proud to know that your wildlife department is committed to finding solutions that ensure that the northern bobwhite quail will be around for generations to come. It's amazing how far technology has advanced, and it kind of blows my mind to think that satellites in space are helping us to better understand the tiny northern bobwhite quail. Hey, thanks for joining us today. For all of us at your wildlife department, I'm Todd Craighead, and we'll see you right back here next time on Outdoor Oklahoma.
Good honor. See him up there, he's the lead dog. Okay, come on in right here. We're gonna approach right at him. Whoop. 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 Good dog. Whoop, 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 whoop. Come on up. Whoop, be ready. They probably run off on him. Whoop, he circled back. Whoa, be ready. Whoop. There's some good action right there. Good dog. Okay, we got five dogs down. Whoop, whoop, whoop. There you go. Good shot.